Okay, so we started with this. And now what we want to do is we want to do the MATLAB part. We found our eigenvalues here. We saw they were complex, but we still persisted, did the same as usual. Then we found the first eigenvector. We identified the real part and the imaginary part, which is the coefficients of the i's. And then we use the theorem to write our solution. Now we're going to check if this solution is true by inputting it back here, calculating the derivative, and see if we get an equality without this, because this is the solution for the homogeneous. And then for this, to guess a particular solution, we broke up this and we found a guess for this part and a guess for this part. We added them up together. We found the derivative, and then again, now we want to determine A1, B1, A3, B3, and also A2, B2. And we'll do that in MATLAB. So let's go over to MATLAB over here. And the first thing that we want to do is we want to define the coefficient matrix. So the coefficient matrix, if you remember, is 1, -4, 1, -4, and 4, 1. And I don't want it to output, so I put a semicolon. Then I want to define the forcing function so that I have it for use later. And what is that? Well, that is 4 times t plus 9 times exponent times 6 times t. And then I have negative t in the second row plus this part right here, e to the 6t. And I don't want it to output, so I put a semicolon. Now I'm going to define my complementary solution. So xc of t, that is going to be, we said, now I realize I made a mistake again. And this is a mistake that I make a lot, apparently. So this is not the end of the theorem. You need to also multiply each of these terms by e to the alpha t, where alpha is the real part of your eigenvalues. So this needs to be multiplied. It's good that I caught it. And I'll write it in red. This needs to be multiplied by e to the 1t, because our real part is 1, to e to the t. And this also needs to be multiplied by e to the t. And over here, we still need to put e to the t and e to the t. All right. So here and here, we're going to have e to the t and e to the t. So let me write the solution now. It's going to be c1 times e to the t. And that's going to be all multiplied by, it's going to be all multiplied by 1, 0 times the cosine of 4 times t minus, and here I need to put a semicolon, minus here I'm going to have 0 and -1 times the sine of 4 times t. And that's going to be my first term, then c2 times e to the t times 0 and -1, all multiplied by the cosine of 4 times t. And then we have plus the vector 1, 0 times the sine of 4 times t. So let's just check that we wrote it all correctly. Now, c1, so that reminds me that I need to declare that variable. Exponent, so e to the t, 1, 0 cosine of 4t minus 0, -1 sine of 4t plus c2 e to the t and 0 minus 1 cosine of 4t plus 1, 0 sine of 4t. Okay, so now that we have this, I'm going to check, well, let's define my symbols, I'm going to define my C1 and C2 and the T. And now checking the complementary solution, that's going to be diff xc should be equal to what? Should be equal to a times xc. And if we do that, we're getting an error here. Dimensions are not consistent. Dimensions are not consistent. Let's see where the dimensions are not consistent. Here, we're saying the dimensions are not consistent. Well, I don't see anything wrong in here. 4 times t plus 9 times the exponent of 6t and negative t plus the exponent of 6t. They're saying the dimensions here are not consistent. Check dimensions. Oh, this is a 2 by, well, this should be a 2 by 1. I'm not sure what's giving me a mistake. Let's write it this way. Let's write it separately as we did before. So that's going to be 4 minus 1. 4 minus 1 times t plus 9 and 1 times e to the 6 times t. I wrote the same thing. Maybe MATLAB will like it more. Maybe there was a mistake that I wasn't able to identify. So let's see what happens now. We went all the way through. We got an equality, so I know that the complementary solution is correct. Now I'm going to define the particular solution, yes, and if you remember, x of p, we said we were going to have an a1 and a b1. Here I need a semicolon to separate the two, multiplied by t, plus we're going to have an a2 and a b2, and plus we were going to have an a3 and a b3 all multiplied by e to the 6 times t. Okay, and now we're going to find the variables a1, a2, a3, and b1, b2, b3. So how do we do that? Well, the first thing is we put it back into the equation just like this one, but now we have a p in here, xp. We press Control Enter, and MATLAB is going to output, and it's telling you, hey, I don't recognize the variables because you need to add them up. And I actually waited because I wanted to show you guys adding them up after we wrote it, and then I forgot. But now that we have this, now we want to matching the coefficient and solving. So to do that, I'm going to look over here and I'm going to say, well, we have a1 by itself, and on the other side we have a2 by itself minus 4 times b2 by itself, and that is it. Remember, we need 3 equations from this and 3 from this because we have 6 unknowns. So now let's look at the coefficient of e to the 6t. That is 6 times a3, and that has to be equal to a3 here minus 4 times b3 right here. Now we're going to look at the coefficients of the t. There's nothing here, so I'll just say 0 is equal to a1, that's the coefficient of this t, minus 4 times b1. Remember, we're just grouping here, and these are my first 3. Now let's check that they are right. So here we're supposed to have negative b1 A1 and 0. Where's 0? Right here. You can't see it, but it's there. Now we look at negative 4b3, a3, and 6a3 here. Okay, I feel confident about that. And now the ones without a multiple to a negative 4b2 and a2 is equal to a1. Okay, so now we're going to do the other three at the bottom. So we're looking at b1, and we have other variables that are just by themselves. Well, we have these two. So 4 times a2 and b2 right here. And now we're looking at the ones that are the coefficient of e to the 6t. So 6 times b3 on the left-hand side, and on the right-hand side, let me put a space there. On the right-hand side, we have 4 times a3 plus b3. And then finally we have the ones with the t. There's no one with the t on the left, so I'll just put 0 is equal to 4 times a1, that's the first one with the t, plus b1, and we have any other t? It doesn't look like it. Okay, so now let me check from the top, b1, 4a2 plus b2. Okay, then 6 times b3 should be 4 times a3 plus b3. And then 0 should be 4 times a1 plus b1. Now that we do this, we're going to put them all in the solve argument, and we're going to ask it to solve for these. So we do this. Now the solve. This becomes the argument. And then we have to tell it what to solve for. Well, we want to solve for a1, a2, a3, b1, b2, b3. And we'll let it output, so we won't put a semicolon at the end. It'll output 6 things, so we need to give it a matrix variable. And we're going to have a1, a2, a3, b1, b2, b3. I'm renominating these, like I'm redefining these after we get the solve, so that we can use them directly without having to rewrite the code. And here we need to separate the variables by a comma, which I did. Now let's see what else. Value sign might be unused. Consider replacing. They're saying it might be unused. Let's see, a1, a2, a3, b1, b2, b3. a1, a2, a3, b1, b2. So let's see. I don't know how I get that. So let's see first if it works with the control enter, and then if it works, I'll show you what to do next. So here it actually shows you only the trivial solution, which means that I must have made a mistake, because otherwise it would show you the results. That either I made a mistake or the guess is not right. So a1 here should be equal to a2 minus 4 times b2. That seems right. And then we have 6a3 should be equal to a3 minus 4b3. Okay. And then 0 should be equal to a1 minus 4b1. a1 minus 4b1. Now we look at this one, and we see b1 is equal to, should be equal to 4a2 plus b2. 6b3 should be equal to 4a3 plus b3. 4a3 plus b3. And then 0 should be equal to 4a1 plus b1. And we should have a1, a2, a3, b1, b2, b3. And it looks like it's not finding the values. So I must have made a mistake somewhere, but I can't see it right now anywhere. A1, A2, A3. This is interesting. Well, let me double check whether I made a mistake or not with some other sources that I have. Let's see. We should have we just need to recheck these. A1 should be equal to A2 minus 4B2. A1 should be equal to A2 minus 4B2. Okay, that one's right. Now, 6A3 should be equal to A3 minus 4B3. So minus 4B3. Here we could bring this to the other side and have a negative 5A3. And then I think, let's see. If I go up here with the f of t, I get a 9 here, but I'm not seeing that 9 here anywhere. So I wonder if I made a mistake there. Yes, right here. You see how I didn't put the f of t? That's where the mistake is, because we're solving now for the non-homogeneous case. But that still doesn't solve it, because this came without that observation. So now we have to rewrite these equations. So we have A1 is equal to A2 minus 4B2. So the one that has e to the 6t, it's going to be this one, and there should be a 9. So a 9 plus A3 negative 4B3. So 9 plus A3 minus 4B3. That makes sense. Okay. And then let's see the other ones. This one didn't change. This one, B1 and 4A2, B2. This one didn't change. Now this one, 6B3, e to the 6t. So 6B3 is equal to 4A3 plus B3. That one didn't change. And then this one didn't change. So let's see now, if I press Control Enter, if I get the right thing. Well, I definitely get an answer, but it's not the right answer. I made a mistake here in finding the equations. In particular, the t had changed after I added the f of t, so I needed to address that. And now I get the right values, and I can redefine this. And since I redefined the variables, a1, a2, a3, and b1, b2, b3, I can just rewrite it, and MATLAB will append these values now to this. And now I want to check if the solution is correct. Is valid. So how do we do that? We find the derivative of x of p, and we say that that's equal to a times x of p plus f. And we want to see if the left-hand side is equal to the right-hand side. So I'll use my trick of simplifying after expanding, and I get that. In here, simplify after expanding, and I get this. Let's see if we get the left-hand side is equal to the right-hand side. Here we do, so we know that that is a solution. So now I'm going to define the general solution, and I'll call it x, and that's going to be xc plus xp. And we've already checked it, but if you want to check it again, checking the validity of the general solution, what you can do is you can rewrite this expression, but now we're going to just have x, which is the overall general solution. And we want to see if we get equal, equal. So MATLAB is doing the work. Now we got equal, equal at the top and equal, equal at the bottom. So we're confident that we did our problem correctly. I apologize for the little mistake here, and I'll see you next time. We're going to do variation of parameters.